I am Mette, and today I will interview the Project Sunride Rocketry Team from the University of Sheffield. Could we start by introducing yourselves?
I'm Dominic Callister. I'm the liquid engine lead at Sunride.
And I'm Merlin Reeves-Dyer, and I'm technical lead at Sunride, overseeing and checking a lot of the work that the team leads, brilliant team leads like Dominic, do as some kind of arbitrary buffer. It's a brilliant job because I get to sort of see what a lot of the different projects are doing and get an in on a lot of the design thoughts and the design process and get to question a lot of it. It's fantastic to see it all come together.
And yeah, my role is, the liquid engine lead. So that's involved with the design and testing and all of that for our Sunfire engine series, you could call it. We've just tested the third one now, but yeah, that's kind of what I do, making sure that...
Could you talk a bit about how your team started?
The idea of the project was to attempt to enter the Spaceport America Cup for the first time. So there was a department and a professor called Victor Fendham who started a small little project with about 5 or 6 people to go to this competition and compete in this competition. So they launched Amy at Spaceport America Cup in 2018, and it managed to get the closest to the target altitude. It was quite lucky considering that it did launch at a considerable
angle.
So I think that was, it started very, very, very luckily. It was a really exciting project, and everyone who did it that first time round went away from it being like, oh, we've got to do this again. So they sort of formalized it within the uni a bit. And then in 2019, they went back to Spaceport America Cup to launch Helen, once again aiming for the 10K ceiling or the 9K altitude category, but they kind of smashed through it. And they ended up going to 36,000 feet. Sorry, I'm switching between kilometers. It became the UK altitude record. So it became the highest altitude that any UK uni had launched to. So then since 2019, we have somehow managed to hold on to that record, and no rocket managed to beat Helen. Over the early 2020s, we had COVID, and that kind of really hindered the team. But there was a couple of concept designs going on at the time. So they were concepting a rocket called Vesna, which never really went anywhere. And then they started concepting Karman Alpha / the Karman series of rockets. In 2022, we started manufacturing Karman Alpha with the aim of launching in July 2023. And we managed to get the 2-stage rocket all put together and launched in America. However, it did not beat Helen's altitude. So Helen's altitude still holds 2 big milestones. We've got the liquid development engine, which I'll let Dominic talk about at the moment, because that's very new and exciting. But sort of the long-term goal of the team over the last 3-4 years has been to attempt to get something to the Karman line.
As with any rocket team, let's be honest.
As with any rocket team. I think it's like the first one that you put down, isn't it?
Yeah, it's the ultimate goal.
To the liquid stuff, what would you say your milestones and the story behind Sunfire is?
Yeah, I guess a bit of background on that as well. From the liquid engine side of things, the Sunfire 2, I don't really know really what happened with Sunfire 1. There's a lot of lost info somewhere. But Sunfire 2 was the UK's first regeneratively cooled engine tested. So ICLR got the first liquid biprop tested, which is very, very impressive. We got the first regen. It didn't fully work, but it kind of started. That whole thing was supervised by Alistair John, our academic supervisor, who then kind of turned it into the Race to Space National Propulsion Competition, which is where other UK unis can show up, test their liquid and hybrid engines at proper industry like test facilities like Airborne and Proto Launch down in Westcott, which is a very, very amazing opportunity for all teams involved. Sunfire 2 specifically was kind of only really final year project students, so they had a load of 3rd and 4th years for their dissertations, do an aspect of that. But recently, in the past academic year, there's kind of been a bit of a shift because we were thinking, okay, we've got an engine, why not put it on a rocket at some point? So Sunride has kind of absorbed that, so it's no longer just final year project students. If there's only actually one this year, it's mostly just within the Sunride team who are sorting that out now. I mean, I'm a 2nd year, I don't know how I got here, but hopefully launching this summer. There's a bit more testing that is required, but that is the milestone at the minute. That is the milestone at the minute for the kind of liquid propulsion side of things. And of course, we recently did successfully hotfire the Sunfire 3 engine 3 times, which is something that Sunfire 2 unfortunately wasn't able to achieve due to channel burn through. But yeah, so it's kind of been an iterative process on that side of things.
Could you talk about your university a bit?
We study both at the University of Sheffield. Truly think it's a fantastic university. we're both studying aerospace. So I think we're doing exactly the same course.
Yeah.
And neither of us went into avionics, but both of us went aerospace.
Yeah.
But it's a lot of work, but I'm truly very happy that I decided to go to Sheffield, especially to study aerospace. I'm from England, so is Dominic. So studying a university in England is obviously a lot cheaper and a lot easier. And there's a bunch of government systems which help us go to university, essentially. I was always going to pick, and I'm sure Dominic was going to pick, a university inside the UK. But I think I chose Sheffield initially because it has so many engineering projects like Sunride. There's a whole host and a whole department, in fact, at the university set out just to help student-run, student-led projects and support student-run, student-led projects. And also, as part of the aerospace engineering course that I'm doing, there's a module which is private pilot instruction. So I've always wanted to learn to fly as well. Sheffield also gave that opportunity as well. And I think it's a really brilliant uni. I think the course is also well divided into theory, but also we have a lot of group building projects. The fact that we got last year, or at the start of this year, around £30,000 to build and run this rocket project and build the projects around it. It is truly fantastic that the university is willing to support that.
Yeah, we're very, very grateful that kind of the fact they have a dedicated department to it is something that is very unique as far as I'm aware, which is a really great thing. I really do like the course. It's just a nice uni. There's just, I know it's very vague, but I like the vibe of it. You know what I mean?
No, it's good. I think Sheffield in general is also a very chill city. People in this are very willing to talk to one another, and it does have that sort of homely, quote unquote, aspect.
Yeah,
I know that now I've been at the uni 3 years, I definitely consider Sheffield my home.
I always thought that I'd prefer like a campus-based uni, but then I came here and I was like, nah, I prefer this. It's a small enough city you can kind of get around everywhere, but it's not big enough that it's kind of almost too daunting in a way. It's like a comfortable size, especially for a university.
Are you planning on doing a year in industry, Dom?
Yes, I am. Not a private pilot's thing, but I am planning, hopefully after my third year, between third and fourth, because I'm also hoping to do the masters, hoping to go out somewhere. Not really sure yet. I need to apply for positions next year, but yeah, that's another thing. Of course, year in industries is.
I chose personally not to do a year in industry or an Erasmus or a placement somewhere else, because I'm doing the masters like Dominic, which is a 4-year course. But I kind of wanted to get uni over and done with, move on to industry instead of getting a taste of industry and then being told no. And I think that a lot of the experience that you get on Sunride with design, build and manufacture, with management, with teamwork, with all of those quote unquote industry experiences, is really brilliant being able to get that.
What are your job opportunities after finishing university?
In terms of like the career path I want to go down, I've kind of figured that I really like rocket engines. So basically anywhere I can do that. There is a lot of companies that do support that and do get involved with it. There's a good amount of industry contact, I'd say, that is like available.
I think that the space sector in general is growing a lot, and me and Dom are both very lucky as two people who really want to go and work on rockets, the actual building / designing the rockets. There is more opportunities than ever before to build / design rockets. So I think in that sense we're both very lucky. But there are lots of international companies that are doing it. But I think in England you have Skyrora and Orbex. Both of those are trying to build orbital rockets. They've been trying for a little while. I think that if either of those in the UK launched a rocket in the next year or before I finish university, I'd absolutely love to attempt to work for one of those companies and get some hands-on experience. But like Dominic said, there's also loads of smaller companies in the UK that do one specific part of the rocket. For example, there's loads of satellite companies, engine companies like Airborne and Proto Launch. You have some military companies like Nammo and BAE. Rocetry.
Kinetic. There's a bunch of other ones as well.
How's the experimental rocketry community in England?
It's great. Rocketry is a small enough sphere where kind of everyone knows everyone, you know? Unis, non-unis alike, just regular amateurs. I mean, like, for example, as I'm sure you might be aware, the Reliant Robin Space Shuttle, like those guys who did that, a couple of them go to our local launch site and we just chat with them. It's really great. They give us advice. They let us know when our ideas are bad. So we're very much in touch with other teams because there's a UK Uni Rocketry Discord server. Just chat about like what they're doing, giving other people advice, sharing their experiences. Because I think in the past, specifically Sunride, I'm not really sure why, but there's a lot of secrecy, which I think was rather detrimental. And because everyone's trying to achieve the same goal, which is just launch cool rockets. So learning from others' mistakes, saying, okay, exactly this went wrong, is a really useful thing, and it moves everyone forwards in a way. And especially, again, Race to Space, Alistair's pretty much mandated that all teams participating in that create a build thread for everyone to kind of have a look at their progress, give advice if they have any, or take inspiration from their designs, which is a really, really useful thing. It just encourages like collaboration and stuff. And we actually got invited ICLR's test site to watch a couple of their hot fires the other weekend, which was a great experience. Lovely people, really enjoyed it. But yeah, it's a very nice community to be a part of. And
I will say on that point, but back to the old geezers, there are a lot of old like amateurs who've been doing amateur rocketry for 40 years plus, you know, and they are brilliant fun, and they're very happy to share their knowledge and engage with us. And like, as Dom hinted on briefly, but I want to add a little bit more information. I don't know if you've watched Top Gear at all, classic old British TV show, but they in one of the early episodes they build a Reliant Robin, which is like a little car, like a space shuttle. They try and turn a car into a space shuttle, launch it with a bunch of solids and Q-class hybrids, and that was Colin and Chris. And there's also an episode where they do the mini ski jump, which I'm not sure if you remember, where they send a mini with a bunch of rockets down a massive ski jump ramp, and send it. It's brilliant. But actually meeting these guys, who personally I grew up watching videos, and some of the reasons why I absolutely got into rocketry and engineering, actually getting to meet them and them to help us so much and give us so much advice and support is really brilliant.
Yeah, they have decades of experience, and it's just like, yeah.
And on that point, I'd say one of the huge things that really make the community in England is the launch site. There's a launch site called Midlands Rocketry Club, and they do a launch once a month. Granted, the weather is okay.
Yeah, it's been pretty bad recently.
It's been pretty bad lately. But granted, the weather's okay. They do a launch once a month, and it's brilliant to see like little kids, like 6 years old, launching tiny little A-class pieces of cardboard, and then like Chris and Colin launching their giant hybrids that zoom up into the air. And in England, it's very difficult to launch rockets because there's a lot of regulation. The CAA are very strict, partly because the country is so small. If you send something tall high into the air, there is a good chance it will land on someone's house. But I think that with EuRoC, so the UK Rocketry Association, actually keeping this launch site going every month and encouraging the uni teams and all the other amateurs to come to this event every month and launch rockets and talk about the rockets they've built has definitely led to the community being so cool, so much fun.
Yeah, and those guys have fought to keep rocketry legal, because like in the past there was question marks over whether even owning solid motors in the UK would be legal, and things like when there was the kind of nitrous oxide ban, those guys fought for rocketry to be an exception to that, to keep hybrids available, because hybrids in the UK, while we can't make solids due to explosives laws, somewhat understandably. I'm a bit jealous of the Americans, though, I'll be honest. But we can make our own hybrids and launch them, as long as you kind of go through the correct streams with EuRoC to keep them informed, just so it's safe. Then it's, those guys have made sure that it kind of stays open for everyone, which is a really, really impressive thing.
What are your active projects in the rocketry team?
So this year we took on a lot of projects. I was technical lead last year, so I had the same sort of chief engineer overseeing role, trying to get the different sub teams on Karman Alpha that we were working on last year to sort of coordinate and come together and the whole rocket to be built and it to launch, very much integration side. And I noticed that it was absolutely chaotic, having like 40 people split into smaller groups, not tiny groups, but smaller groups, all working on a little subsystem of the rocket, meant that it was quite difficult to keep people like engaged and doing it. This year, as like the team sort of decided going into this year that it would be a much better way of laying out the team to have a lot smaller teams working on a lot larger projects, because then the 7-8 people on the smaller team are way more engaged in the project, because there is a lot more work to do than those 8 people can initially do. They're really going to have to work with each other and bounce off of each other to turn the project into existence. So we started with, at the start of the year, we started with a bunch of different projects. We had Karman series, which was continuing on from Karman Alpha, so building Karman Bravo. And I think that the big goal for that this year is to launch on the 15th of June back at Friends of Amateur Rocketry in America, and once again try and beat Helen's altitude record, beat our own altitude record, so that actually engineers on the team can be like, yes, we got it, and get a rocket above 100,000 feet, which is in of itself an amateur rocketry big W. There is a team doing recovery at the moment, so we built a team, 7 or 8 people, led by a very good engineer, who are designing a steerable parachute system. So I think there was a European team that did it before, EPFL, I want to say, but I could be chatting total shit. But I know that another team has built a steerable parachute system, and the idea is it releases a parafoil and has 2 control lines that actuate the corners of the parafoil to get a turning moment. And they're making brilliant progress on that, and they're pretty much in hardware and manufacturing stage, so they're going to launch that and test that at MRC. And their long-term goal is to go to the Macrahanish rocket competition this summer and attempt to launch it on an L class to almost 3 kilometers, and hopefully fly it right back to where it, do a little flyby of the stand, a little circuit, land it where we want. That's the aim. We have the experimental team, which have been building smaller rockets, trying to get newer members to have more experience, but most importantly, to sort of build some test platforms where we can test new technology, such as our in-house avionics and deployment boards, our in-house tracking boards, and also arming, just mainly avionics, to be fair, mainly avionics. But there is also a rocket called X4, Experimental Series 4, which are trying to do air brakes. And there's also some research projects going on about possible canards and controllable fins. So that's all very exciting. Avionics, as I hinged on briefly, they're doing tracking, deployment, llama, which is control for possible more complicated
liquid stuff.
Liquid stuff. Am I missing one? I think I'm all right. Oh, armadillo, that's it.
Yes.
A little like Wi-Fi arming switch, so we can remotely arm shit nice and easily. I have a really reliable board on that. Is that everything except Sunfire? Because I'm just going to chuck it over to you. Analysis, of course, we have analysis, which are essentially do a lot of ANSYS research projects, / other general research projects to both answer really complicated questions that we have on the design and manufacturing side of the team, such as, will this break? They did brilliant work designing the supersonic and subsonic fins for Karman Bravo, both this year and last year. So that's all very interesting stuff as well. But then we've got liquid stuff, which
I'll explain a bit more on that. So yeah, on the liquid side of things, then the beginning of this year we had all of the kind of progress made from Sunfire 2, which was very useful. But there was a couple of like things that we needed to kind of iron out. So at the beginning of the year, it was very much, let's just make an engine. But as we kind of got further in, we were like, okay, we're making really good progress with this. We managed to get a sponsor for the engine, so that cut down the cost significantly. So we had a fair chunk of spare budget. So we decided to start working on a rocket called Desert Winds, which is our liquid rocket that is hopefully launching also on the 15th of June alongside Karman Bravo at Friends of Amateur Rocketry. It's going to be a busy day. It's going to be so, if it would, it'll be so cool. But
launches in 1 week.
Gosh, yeah. So, I mean, that's aiming to be the UK's first successfully launched liquid rocket. The bar for success is very low for that, in that it's just got to get off the pad. And beyond that, I don't really mind. Well, whatever happens. I kind of just want the engine to light. But yeah, so we've got a kind of the engine team working on, obviously, the engine. And we just successfully fired Sunfire 3. So we're making a flight version of that, which is just stripped down the instrumentation, made it easier to integrate into the 6-inch airframe and general stuff like that. But then there's also the feeds team who are working on, of course, the propellant delivery system for that. And yeah, we've taken a very kind of simplistic approach, you could say, but just kind of bare minimum to get there. So I think we've got like 3 valves, including like the valves on the rocket and the ground equipment. There's only 3. So we've tried to cut down on any complexity really, and just kind of said, okay, we want to launch this rocket with as little, I don't want to say effort because that kind of makes it sound lazy, but there's been some good thought into thinking, what do we need, what do we not actually need, and how do we make it as kind of smooth as possible to get there.
I think another really good point is when we launched Karman Alpha last year, it failed. We failed recovery and just after second stage ignition, we had a motor blowout. The process of going to America, launching the rocket breaking, coming back to England and starting the design process of Karman Bravo definitely taught us that you can learn so much from actually just going out there and doing it. We spent 2-3 years designing Karman Alpha, and it had fatal design decisions in it that would have killed it from the very beginning. The sooner we could have launched the rocket and seen what had happened, seen what things went well, seen what things went badly, and learned about it, the sooner we were able to move on to Karman Bravo, which is why I think it's such a brilliant thing that the Sunfire people are just trying to go for it as quickly as possible, just to see if we can get to America, get a liquid rocket, and attempt to launch it. Because if it doesn't work, next time the chance of it working is way high.
Yeah, definitely. And just kind of dealing with all the issues that will come along with that, because there will be. We'll encounter like, oh no, what do we do here? Moments, you know what I mean? Before we even get to America, when we're in America, I'm sure there's always the like mandatory launch day catastrophe that every rocket has. Every single, I can't think of one where it wasn't like, okay, how on earth are we going to deal with this? And I mean, most of the time we do work through that. Other times the second stage does blow up. But yeah, and we were going to go to America anyway for Karman Bravo, and so we're like, we're going there anyway. Why don't we just attempt this as well and see if we can pull it off more than anything? Because we'll gain so much experience from doing that, and we have even currently we've come a very long way.
Yeah, it's doing it, yeah, or even just attempting it, making it. The project has pushed the project forward so much further than if you'd made the goal something reasonable at the start of the year.
Yeah. Because there was the ridiculous timeline that I admit I thought was ridiculous. I didn't propose this was to launch Easter.
It would never have worked.
Never would have worked.
Because MRC had some really bad weather days in February and March, we wouldn't have even been able to do Bravo.
No,
we would have just had no chances to test anything.
We just said, okay, let's aim for Easter, because we'd make more progress than we would if we were like, okay, it's going to be summer or next year, for example. And so when it comes to the point where you're like, okay, Easter is, even if it was just feasible with a perfect timeline, okay, we'll move it back to the next one. And then as soon as you do that, the next one feels a lot more achievable because you've already been working to the Easter one, whereas summer now feels a lot more, okay, that's actually realistic, rather than at the beginning of the year saying liquid by summer, that's impossible, you know? So it's kind of just, it's more just, I don't want to say tricking yourself into getting it working, but it essentially is.
Motivation, I definitely think.
Yeah.
And I think that having tight deadlines on these kind of student-run, student-led projects, even though it's totally arbitrary, like we decide the deadline, not the time I decide the deadline. Like it is literally pulled out of thin air, but having a ridiculous deadline does mean people get more engaged with the project.
How do you recruit candidates for your team?
I've done 2 recruitment cycles, and the first recruitment cycle was quite different to the second one, but there were similarities. Like initially, like going out into the uni, we will try in the first few weeks of term to get our posters and our posts out and encourage people to go to the open days, encourage people to join the team as much as possible, or apply to join the team as much as possible. And then within the first few weeks of the term, we will do interviews, and we will decide on team leads as well. So I think it's usually up to the committee to sort of do an interview process for the team leads, but it's very open, because in reality they're passing over to the next team, who then can decide how they want to set out the team, who they want to set out as their team leads and committee, like immediately. Once that's sort of defined, that group of people will go into the interview process, and basically they can choose out of all the interviewees who they want on their team, who they think will be a really good part of the team, who really cares about the project. We tried to keep the teams as small as possible, which is a bit brutal when it comes to recruitment. We had like 170 applicants and we accepted like 50 or 60.
And that is, I say that is the most gutting thing, that you do have to turn people down, because in an ideal world, we take on everyone, but there is a lot of applicants at the beginning of the year. I don't know if this is just a thing for any rocket team, but obviously rockets are cool. People are going to want to do it. So that kind of forces us into having a application process where you kind of have to submit, I don't know, answers to a couple of questions and then interviews, because of all those people who apply, you want to get the ones who really want to be there, you know, not just with the CV who are like passionate about rockets, who just, you know, want to get hands-on involved with stuff. So it is hard, and you do feel bad having to say no to people, but it's just the kind of situation we're in with the number of people who do want to join.
And I think it's a double-edged sword as well,
Yeah.
because whereas if you want to be quote unquote nicer and accept more people, it is still student run and student led, and running a team of 170 people is very different to running a team of 50 people. And I think that when you have smaller teams of people who you make sure are really dedicated, and by having an interview process you sort of make it seem like they have to commit, there's like a unsaid thing where it's like, well, you've got through the interview process, you're one of top 50,
Put in
you
the
need to put in the effort, you need to commit to the team. And actually having a much smaller team of people full of those really committed members is how loads of stuff gets done and progress is really quick. So even though initially it comes across as, I know it's really difficult because you know some of the people who are interviewing, but the competition is fierce.
It
There's
is.
lots of very smart people coming to the uni to do aerospace or engineering, or even more than that, to be fair. We have people in other departments as well on the team. But I think the thing I always look for the most is, do they care? Will they turn up to every meeting, and is it something they're really passionate about? And even if they don't have as much technical know-how or experience, if they really demonstrate like a want to commit to the team and put in loads of effort, that is the best thing, because no one really knows what we're doing at this point. It is student run, student led. We are learning. So people who are going to just be an integral part of the team and put in loads of effort are always going to be. That's what I think. That's always what I'm looking for.
I think on that point, you could have like the most brainy person ever show up with like crazy experience doing X, Y, Z. Be like, okay, this would be amazing. But if you get to them and they just don't seem like they have that kind of like drive, and if it's like, oh yeah, well, I want to join the team because it'll look good on my CV.
Yeah.
Like, you know, that we take someone who has much less experience in that. It's just like, I really love rockets, you know. It's
Kerbal space
not
program. It's my
that I play
favourite
KSP.
thing. Like, yeah, that's one of the main reasons why.
Yeah, but it's mostly enthusiasm and just kind of, I mean, like knowing a bit, obviously, like you got to have a bit of background and like say, oh, I'm really interested in space and da. But it's just the kind of, are they going to show up to meetings? Are they going to go to the workshops when we are actually doing manufacturing, stuff like that? And it's not. I mean, it's even if I would still do as much work in this team, even if I got no credit on CVs or stuff, because I just enjoy it, you know. And so it's a lot more than just experience to push your career forward. It's a hobby. It's something you enjoy doing. It's like, oh yes, I want to do this because it's cool, and that's kind of what we look for in other people who are joining. I'd say at least that's what I look for.
When your engineering product sort of becomes your baby, you become like,
Yes.
you really care about the outcome. It stresses you out, and you become emotionally happy. That is like that kind of love for the project or what you're doing. It's those kind of people that really have that, who together make such a brilliant team. To be fair,
I have very strong maternal instincts for that engine that we tested. I was like, it's like sending my baby off to school for the first time. It's like, it's going to do what it's going to do, and I have no more input. You know, it's like, it was scary. It was scary.
What can members learn from joining your team?
Of course, you learn stuff from your course, but it's the actual just doing it, like saying, okay, here is my goal, and just getting there, going through all the motions, especially like the teamwork, working with others, like just practical skills more than anything, and just being in that kind of team environment where everyone is working towards this common goal. It's not just, it's very different from a course where you're like, okay, I've got to do well in my exams to get my degree. I've got to do well in this group project to do well in my degree. You know, it's everyone's kind of working towards like a common goal, and it's just figuring out how to work through that, because of course you do encounter challenges, and even within the team you have disagreements over how certain things should be done, and stuff like that is probably the most beneficial thing that you can get out of being part of for Sunride, for example. And it's something that I'd say I've benefited from going into like a professional career. I kind of know what to look for in a way, you could say, but also know how to deal with certain things. And yeah, I think that's the main thing. Of course, there's a technical thing, the CAD design, the coding, blah blah blah, all of that stuff. But I think the main overarching thing, at least in my opinion, is that kind of working towards that common goal alongside other people. It's the main benefit.
Yeah, it's true. And I think it's the first time you do so many things. Like within the team, most people have not yet had the chance to work in a large team with 40 grand budget, £40,000 budget, they've not had the opportunity to build something to that high precision, that is that large and that valuable, to have essentially all the design decisions. It is just within our team,
Yeah,
it's up to us to sort of figure out how to cross-check, how to figure out like what decisions are good, how do we go through the design process into the manufacturing process. And I think because none of us have ever done it before, and you're all sort of doing it together, both technical wise, like actual skills like fusion, like Dom said, or team working skills and just learning how to do it. I think one of the ones that I found most interesting was simply just seeing a project from the beginning to the end, like actually getting to observe concept, design, manufacture, the circle that sort of goes design, manufacture, then into testing, then watching some more designs change because your testing showed some other stuff, and actually watching the whole design process through, trying to keep it to timeline all the way to a point where you're at the launch site ready to launch. It's truly brilliant experience. I do think that the skills you get are very wide ranging.
And another thing I just thought, working under stress.
Yes.
Oh my word, launch days or test days. Whew, you've got to
a lot about yourself as well, like how you react and interact in different situations. I think I've learned a lot about myself doing it.
Yeah, definitely, me too. And like I think I even the progress is, at least from me, I've noticed myself get a lot less and less stressed. Like even when, like in my first year, I was involved with experimental, then called test series, working on Karman Mini, which was a tiny little rocket to test avionics stuff, and then Test Rocket 2, which was our 2-stage test rocket for Karman Alpha. And the initial couple of launches for that, I was so stressed. But then as we did more and more, and even the recent engine test, of course I was stressed for that, but I'd kind of learned how to deal with it and kind of just stick to what we like, to the plan basically. And if there is hiccups in that, just kind of think, okay, how do we sort this out? Rather than go, okay, we got to do this, properly think, okay, how do we do this sensibly and without letting kind of the stress get on top of us? At least in my opinion, or my experience, I should say, is that's kind of what I've learned from this experience.
The design process from concept to launch is a very tricky, interesting question. I know that when I first got tech lead and started setting out the sub teams and the team leads to design Karman Alpha, the concept phase had been sort of done. We were trying to move from this design into the manufacturing phase and sort of checking the final parts of the design to build. And we were basically stuck for a few months, noticing that a lot of the designs in the concept, when we actually tried to build them or talk to people about building them, it was really, really difficult. And then as we went into manufacture, like trying to figure out manufacturing techniques, like one of the first things that we built at the start of 2022 was this terrible drilling jig, but it was a nice attempt to sort of have this system that held a drill and could move a drill up and down the length of a body of the rocket, and then sort of act like a pillar drill, so we could attempt to get really accurate drilling. But we ended up just drilling out all the holes to be oversized and filing them into tolerance. So when we started the next year and we've sort of got the chance to concept design and manufacture, we sort of created right at the start of this year this sort of like mini workflow diagram, sort of represent the design process from concept all the way up to manufacture. And I think we've got it pretty good, to be fair. We will sort of set out an initial set of requirements pretty arbitrarily, nothing too specific, just to sort of get a feel of what the project is. For example, Steerable Parachute System, or the successor to Karman Alpha, Karman Bravo. Then we spend a little bit of time sort of doing concepts where lots of people throw in different ideas. You do some quick fusion models, nothing too concrete. Then sort of once we feel like that we have an idea forming and the project sort of has a bit of a scope to it, we'll enter the design phase and we'll start doing systems. We have a way of organizing our fusion designs and a parts list that copies our fusion design, track the progress of parts, make sure that we have a list of all the parts. We have a brilliant finance system as well that lets us do ordering. So then we're in sort of the design, ordering, concept phase. That goes on for a little bit, sort of flesh out the project so each part has its relevant documentation. Each engineer knows what they're working on. There is a progress to it. Then we sort of usually do some design reviews and then start going into manufacture. And then sort of starts the loop of sort of you manufacture something, you test it, you realize it doesn't quite work as possible, you redesign it, you manufacture it again. And trying to get through that design process on a timeline that you want to get through it on, so that you have all the hardware built on the launch day. Just generally how I try and lay it out. Well, our projects stay on time.
Most of the time.
Most of the time.
I think also from the kind of, specifically with the because within Sunride, liquid propulsion is a pretty new thing. This academic year, is when it started, really. It's when we had a dedicated, like, proper propulsion team within Sunride doing bipropellant stuff. And in order to get like a rocket built for that, I think that we took a very kind of, this was a mantra that I picked up from certain individuals in the amateur rocketry community. It's just like, question your requirements, question why are you doing certain things. There shouldn't really be any arbitrary decisions that, or just adding complexity for the sake of it. I'm a very strong believer in just working exactly to what you want to achieve and not adding anything else. So for the engine, it was like, I'd say the engine was as simple as it probably could be. Using a simple type of injector, simple like mounting things, one part chamber, and and not really overcomplicating it, not striving for optimization where you don't really need it. So like the engine, I do not care about efficiency of it. The ISP is awful in comparison to like other engines, but we don't need ISP. Yes, it would get more altitude, but again, we're not going for altitude. So why focus on increasing your specific impulse? And especially in the rocket, because it started life as a lot more complex system, but just by kind of thinking, okay, what is this system required to do? And just kind of thinking, oh, it only needs this, this, and this. And you can just knock off loads and loads of parts to make it more and more simple. And I think there's a lot of beauty in a simple system over a complicated one that does the same thing. So that's the kind of simplicity over everything is kind of the design philosophy for Desert Winds as a rocket, which I absolutely love. I really like it.
How do you test and measure the performance of your rockets?
Testing wise, we try and do all our testing at Midlands Rocketry Club. As we said before, the Rocketry Club and the little field that we get to launch out of basically means that we can build our hardware and launch our hardware to much lower altitudes. Granted, it's not liquid propulsion, and actually get some really good measurements from it. See if the designs that you've laid out have worked. I wouldn't say for most. So obviously there are flight computers flying on all our rockets. We'll get acceleration data. We'll get a sort of profile of the flight, GPS track of the flight. You'll understand all of that. How much of a success it was. I think, like Dominic said before, our main goal is always functionality. If you've designed something to do X, Y, and Z and it does X, Y, and Z, then we are in the clear. We are absolutely in the clear. I know that when it comes to the liquid engines and testing at Airborne, there are some very fancy data acquisition systems.
Yeah.
I'll talk about.
So, I mean, for the engine, it has many, many nicknames, Pincushion being one of them, from the number of thermocouples we had. And we might have overdone it with the thermocouples, maybe. But again, we were testing it airborne, which isn't cheap for a day outside of Racer Space. Luckily, Racer Space is funded, but we did one earlier, and we wanted to make the most of the facilities they had there. So they had this amazing DAC with lots and lots of inputs. I think they've up to 32 or something, but we used 24, I want to say, for thermocouples and pressure transducers and things like that. Because while the engine worked and all of the sensors gave fairly unsurprising readings, had it have not worked, that sensor data would have been so valuable in figuring out what went wrong, which was the main issue, I'd say, with Sunfire 2. It had its issues, but I think the biggest issue was the fact it didn't have barely any instrumentation. So the channels failed. We are still not 100% sure on exactly why. There is theories that are more likely than others, but there's not I wouldn't say enough concrete like data to back up some of those claims. So we were just like, okay, we'll change what we can to get it working on the new engine, but if it doesn't work, we want to know why. So that's why we have so many thermocouples and pressure transducers dotted around the engine. And luckily they all said, yep, all works good. So that's why we're stripping a lot of them off for the next engine, because we know it's a decent enough system. And also for our test stand as well, we are looking at kind of lab jacks and stuff like that for data acquisition, just keeping it simple like that by using commercial stuff. And yeah, so I'd say that's the main thing, at least from the liquid side of stuff.
Do you use AI during the design process of your rocket?
No, I think I'd ban anyone from doing that immediately. I'm a skeptic of AI, just in general. I think that it's a brilliant tool at the moment. I think it sorts through an incredible amount of data, but most of the generative AI, we're talking about generative AI, the algorithms are based on probability, which means it is actually rolling the dice to try and get it most accurate. But in rolling the dice and trying to figure out the answer through sheer probability, it is going to lie to you. It is going to come up with random stuff that you don't really understand, or literally has no logic, because it is randomly generated sometimes. It's randomly generated and then tested and compared against actual data to see how accurate it is. So I think that when it comes to AI, especially in engineering, I think it's going to take a long while for AI to sort of get to the point where it can design things well enough that we can guarantee as human exactly how it works, understand all the reasons why the AI put all those design decisions in, and not just have random design decisions and things. Especially in aerospace, you want to know why everything on the rocket is there for a very specific reason, and you want the logic behind it to be traceable back. And I think if you use AI in design, that's going to be a little bit difficult. In the same way, you're not going to get an AI flying an aeroplane anytime soon, because if the aeroplane crashes, it's going to be near impossible to figure out exactly why the AI made the decisions that led to the aeroplane's crash. Like the logical chain that goes backwards is very difficult to see. However, with that being said, I think when it comes to data and sorting out stuff, like if a new AI came over, like an organizational AI, and sorted out our Google Drive,
Please.
I could see that being really, really, really useful. But when it comes to design, I don't think I'd want to use it yet. I don't know. What do you think on it, Dominic?
I mean, in terms of when I use it, of course I use ChatGPT for coding, because I'm quite crap at coding. So if I need a bit of help with that, then I just ChatGPT, how do I do this? And it does help. Of course, I'm not over reliance on it. And I think a lot of the kind of generative design stuff recently is within additive manufacturing and 3D printing. And I'd say there is use cases. In engines, it's kind of tricky, because if you want X amount of thrust, you need this shape of engine. There's not really that much ambiguity to that. Of course, there is stuff you can do with cooling channels or like support structures, because you have that kind of added freedom of you can make pretty much any shape with metal 3D printing. I wouldn't like using it for the sake of it, because if you do need something like, I don't know, I wouldn't have got enough experience with it to properly comment on it, I'd actually say.
Yeah.
I think it will be very useful in years to come. There will be very definite use cases that will become, day to day for any engineer. But I think, like Merlin said, the thought process to get there and the actual justification of design decisions, and also just being aware of all of the physical factors that play into it. You need to give, like, the AI doesn't come up with new concepts, really. I mean, I'm not a computer scientist, so I might say something that's completely wrong. I want to make that absolutely clear. But you feed it the data and it gives you a result based on the data. So it can't come up with something that's outside of that data set. And I think that, I mean, humans, it's kind of the same thing. We learn stuff throughout all of our childhood and throughout all of our life. We are taking in information that we can then apply. But because as humans, we have such a wider array of stuff we take in than AI, than any data set you could feed an AI, there's so much more to pull on. So I think that it's going to be interesting where AI is useful in years to come, but I don't think it can solve everything. It's kind of what I'm saying.
How do you promote your team?
Oh, we have a brilliant media lead called Stephen.
He's a great guy.
I love him. I love him very much. And to be fair, he was our media lead last year. So we have our LinkedIn, which is actually more run by committee. And we always post about all our things we do on LinkedIn. I think that's the most up-to-date, most like if there's a new thing we do, first place we'll post about it is on LinkedIn. We will also post about it on our Instagram. We'll post little leaks and slightly more fun things on our Instagram.
Yeah.
But then when it comes to YouTube and content, we have made a bunch of YouTube videos in the past. Stephen is a very good graphic designer. So actually getting some of that content online is really nice. If you haven't checked out the Sunride YouTube, please check out the Sunride YouTube. Little plug. But I think the big thing that we're working on at the moment is we're trying to make a Space or Nothing style documentary in classic student rocketry team style about the Karman Alpha launch. So the trip to America that we did last summer, because we got loads of footage from that. And then a little bit of a hint at the next launch that would be coming up very soon in that documentary. And I think that's going to be the next big piece of media that we're going to release to promote our stuff.
Yeah, because there's a lot of footage from that trip that's quite funny, and it's just kind of taking us through like how we got there, what challenges we faced, why it went wrong, and stuff like that, and what we learned from it. So yeah, that should be a fun watch. There's a lot of funny little clips in there.
Yeah, it's a very funny documentary. To be fair, it's very silly. Stephen has done a very good job cutting out. I know that recently we were he's set up at the university, they've got this brilliant TV studio. So we were in pairs basically doing like post-launch interviews for the documentary in a very nice, well-lit, nice cameras, different angles. We're trying to make it like actually high production quality. And Stephen and the people that he's working with to make it, Stephen's doing business, but he has a passion for graphic design and making documentaries and media and film and all of that stuff. So in the same way, it's like another project in that sense. There's effort is being put into. But I do think it'll be brilliant. I think we're going to release it probably May time, ideally, end of April, early May, so that it goes out. We can put a bit of hype behind it, but it sort of will hint at the fact that we're going to go to America within the month, launch Karman Bravo to hopefully make sure that what happened at Karman Alpha doesn't happen again, and probably hint a little bit at Desert Winds because it will be in the next documentary. It will be in episode.
The UK rock competition, which I was part of in 2019, I want to say. It feels longer ago than that, but which is kind of an opportunity for UK high schools to get involved with rocketry, launch a little rocket with an egg on board, see if they get it back, see if it breaks. It's a cool little thing. We go out there. We mentor a load of UK like local schools, just kind of give them a bit of advice, help them with the designs. Of course, they do most of it, and we've got our own degrees to get. But yeah, it's a really nice opportunity to kind of inspire the kind of next generation of people who are going to be doing exactly what we're doing and hopefully more. So that's a kind of cool little thing. But that's more promoting rocketry rather than ourselves, I'd say. But yeah.
Would you like to join EuRoC?
I would quite like to go. We would probably launch a liquid there. I mean, of course, the current plan is to launch Desert Winds at FAR because they let anything launch at FAR. So, and we're going there anyway, so it kind of made sense. And we do need to actually contact EuRoC to just ask about whether they'd be happy with our style of rocket, because from what I've seen at EuRoC and from European teams in general, is that they make quite complicated systems that encounter issues that prevent them from launching, or anomalies during launch, which is kind of what we have desperately tried to avoid with ours, because we want to get it off the pad, really. Yeah, so we're using like a concentric tank architecture for our liquid, involving nitrous self-pressurization, but also using a piston to pressurize the fuel, which is commonly done over in the States by the half-cat rocketry guys and a couple more, some unis, some other amateurs, and a potential liquid space shot coming up from some of the guys over there, which is really exciting to see. And we've also adopted that way of doing things. And yeah, we kind of do need to just check to see if EuRoC would be okay with that, because it's not really been done in Europe before. But I think if it was adopted by a lot of European teams, then there'd be a lot more successful launches, because it really does make the system much simpler. Much
Yeah,
more.
you don't have any control on the rocket at all.
No, I mean, for example, we are having the only electronics on Desert Winds will be an Easy Mini and a Stratologger in the nose cone, and maybe some RF beacon for tracking. The actual servos that control our valves are controlled from the ground. The ignition is from the ground as well, so it's a very kind of minimum viable.
On fire and hope it flies. Yeah.
Yeah.
But with EuRoC in general, I think that it would be lovely to go to EuRoC. I would really like to go to EuRoC. I think one of the most brilliant things about the competitions, there's a reason why we're going to Race to Space and Macrahanish, is you actually get to meet the other teams and talk to the other teams and see their designs. And I think for that aspect, we'd absolutely love to go to EuRoC. But I think currently our main mission goals at the moment usually lie at FAR, because we know how to get there. There is, for our altitude rockets, you can't launch those at EuRoC. We're trying to go to 40 kilometers into the air, which is a little bit above the EuRoC altitude ceiling. And then for the liquids, I'd say that the fact that EuRoC has such a tight launch window system means that we are much more likely to get a launch at FAR, because we can kind of chill out and mess around with the rocket for a much longer period of time. All the systems are a lot closer together. It's a lot easier to, I think, do the launch operations. But I personally really want to apply for EuRoC this year.
Me too.
I think we should apply, and I think when the EuRoC applications open, which I believe is going to be really soon if they have not already opened, we're going to try and apply for that with Desert Winds, essentially.
I mean, if we get it back, then
ideally the rocket works and we get it back and we simply polish it up and relaunch it, which would be...
That's a big question mark if we're getting Desert Winds back. That's a huge question mark. If it gets off the excellent. If we get it back, I don't want to say I'll be surprised, but liquids in general have a poor recovery record, and this is our first liquid, so you can kind of see my attention there.
It'll be interesting to see how it plays out, but at some point soon, in the next 2 years, you almost certainly will see Sunride at EuRoC.
If our application's good.
If our application's good. Very true.
What are your goals for the competitions?
So I guess I'll start with Race to Space on that one, because this year it'll be the second year that it's running, and the goals there is like points criteria that Alistair's laid out. One of them being efficiency, which I'm opposed to, but it's Race to Space is called the competition, but it's kind of just like a free test for teams to try out cool things or just get engines working or try out some kind of funky new tech. Our goal for that is we're trying to go for, because Airborne, the test site that is held at, or one of the test sites, they are getting a larger IPA tank, so we're aiming for a 20-second burn there with the same regen we fired there previously. And also, if that all goes smoothly, then we're hoping to do a shear coax type of injector rather than an impinging injector that is the one we currently use, because that'll be cool to see if we can. That would hopefully increase our efficiency a bit, which I'm not opposed to doing if we have the engine working beforehand. So that's kind of our goals for that. I know there's a lot of other teams doing a load of really cool
Macrahanish competition.
Yeah.
The recovery team doing the steerable parachutes, as I mentioned briefly before. They're going to go to Macrahanish. I know that Ed's personal, what are our goals for the competition are get the Parafoil deployed in a state where it can be controlled. And hopefully the big, we've ticked all our goals, is to do a flyby of the crowd. It should be possible. We've designed it with a glide ratio that should make it well able to do a flyby. But I think our main challenge with that is going to be deployment. But luckily we have lots of MRCs to test opening the Parafoil and make sure that our system of opening the Parafoil is very sound. What other competitions are we going for? I was going to say we currently, unless we apply for EuRoC, in which case our competition will probably be get as close to the altitude as possible / get it off the pad.
Get off the pad.
Get off the pad. I think that our wider sort of the larger competition is the UK altitude record, which Leeds are going for, Imperial are going for, Bristol high altitude they're going for.
Obviously they're going for it. It's a record. Exactly. Records are designed to be broken. That's the whole point. But there's a lot of people going for it, so it's kind of seeing if we can keep it for ourselves more than anything. But there's a lot of really good teams full of great engineers trying to break that. So it'll be really exciting to see. I mean, competition even if it's not an official competition, like competition for a record or for highest thrust engine, for example, we had that initially with Sunfire 2. Imperial snagged it back with their Thanos R, and then we took it back from them with Sunfire 3. And I think they're gonna. I told them to try and break it with theirs, to try crank theirs above what it currently is. So they're probably going to take it back within the next few weeks. And it's kind of this really cool. Just everyone's pushing everyone to do more cool stuff. And so the informal competition, like for the altitude record, it's kind of pushed everyone to kind of really think about how they're doing it and how they can maybe get the edge over other teams. And it'll be really interesting.
The really nice thing about the UK uni teams at the moment and the competitions in between the UK teams and all these unofficial competitions like most powerful engine, first UK liquid launch, highest altitude launch. It's really nice having these competitions, but also having such open dialogue with all the teams that are competing with us and going to the same events and seeing them test their rockets at the same time as we're testing our rockets.
Yeah,
it's very exciting.
And I think this is something that I've very much pushed for. It's just being completely open with what we're doing, like just not really holding anything back of exactly how we're doing it. If someone asks, we will say, So if anyone has any questions over any of our rockets, please do send us a message, and you'll get a hopefully detailed answer on that. Because it's beneficial for everyone, and it's just nice to see. So yeah, this year we've definitely pushed for being open, and I know a lot of other uni teams have kind of followed suit, which is really, really cool to see.
How do you see rocketry evolving in the future?
I think that rocketry is evolving so much. I think it's the space sector is one of the fastest growing sectors at the moment. And I do think, especially within the UK, Sunride gives people experience to go into rocketry immediately on leaving graduating uni is really, really, really important. It is already playing a part. I know for a fact that there are like RFA, Rocket Factory Augsburg, they had a couple of graduate engineers from Sunride that come back to us with missions to recruit more Sunride engineers, because it is experience. It is one of the only places you can get experience. And I think going forwards into the future, it's only going to become more prevalent. Like, as there are more space companies in the UK, as Orbex and Skyrora expand, if there are any new space companies that come along, they will be hiring from the pool of Sunride engineers, but also a lot of the other engineers at other uni student rocket teams.
And I think in general in the UK, there has been teams like rocket teams in the UK, especially from unis, who have been going for quite a while. But over the past couple of years, there's been a sudden boom of them, just cropping up pretty much everywhere, which is really cool to see. And I think because of course the Americans have done loads of these milestones have been done already, but in the UK they are still yet to be achieved. So I think that there'll be a lot of progress, kind of almost doing that from all the UK teams, and just it'll be cool to see where it goes. There's already dialogue with the CAA over changing some of the regulations that is actually limiting rocketry in the UK, such as the impulse limit, or especially surrounding liquids. But of course, nothing's confirmed or sorted yet. But there is motivation from everyone to kind of to expand this hobby and this thing, and hopefully expand the career opportunities for us and future rocketeers.
How much do you build your rocket yourself, and how much do you outsource to sponsors?
So to be fair, I would say one of the drawbacks of the University of Sheffield is there are not as many CNC machines or large ability to use the workshops as we would like. There are lots of stuff, and we do try and do as much of it in-house as possible. I think over the last year, we've got better at doing more of it in-house. For example, the steerable parachute system is entirely in-house. There's not a single bit outsourced. Whereas, for example, the engine, that would have been outsourced to our sponsor, or the fins and the nose cone, a lot of the metal CNC'd parts. We have a company / guy who helps us find people to make them for us very cheaply. But I think it's also very nice outsourcing sometimes, because you get very high precision parts built very, very high standards. However, it would be nice if we could do it more in-house. I usually try and get people to figure out how to do it in-house. But for example, the water jet cutter at the uni is tiny, it's always broken. It would be absolutely lovely if the uni had one of those huge high massive water jet cutters that can do like the angled cuts down the side. The possibilities would be endless. But no, we do outsource where we need to outsource. We won't really limit design decisions to make sure it's made in-house. Like if the team leads and the engineers and the design engineers decide that they want it made in this certain way and we cannot make it in-house, we will outsource it. We have the funding to do so. But it is brilliant fun to do it in-house because you get to do it yourself. You get to learn the experience of doing it yourself. I think over the next year, we're going to try and do some more wet layup in-house, which we are yet to really get our hands on. Most of our carbon fiber parts have been done with pre-preg with external companies. But yeah, over the next few years, I know that I'd definitely like to try and do more of it in-house, but it is not always possible.
Yeah, and I think from the engine side of stuff, we are trying to start doing more and more stuff with the uni's additive manufacturer guys as well. So trying to get an injector out of them, a couple actually, seeing what they can do for us. They did a CT scan of our engine, which was kind of cool. Sometimes parts are just more than we can do in-house. So yeah, we'd have to do that outsourced.
What software do you use to design the engine?
For the engine specifically, we actually use Fusion 360. Oh, they changed it. It's just Fusion now, isn't it? That's how we do most of our CAD. We are looking into different softwares. So we'll see what happens over the coming weeks or months. But the majority would still use Fusion for doing the majority of the CAD because it's just nice and easy.
Do you use our RPA?
Oh yeah, RPA as well. Like this is another thing. One of my opinions on liquids is that you, at least in our case, we did just use RPA. I mean, of course, you've got to understand why RPA is giving you those numbers. So understanding the theory of like engines, about how, what the equations mean, is really useful and important if you want to actually use RPA. But we didn't really do any in-house code stuff. We did a bit of in-house code, but only for what, like, specific things, because in my mind, if you spend too much time on in-house code, that's just procrastinating building the actual engine itself. So we kind of thought, yeah, RPA is good. Let's just use that. It gives us what we want to get. As long as we understand why it's giving us that, then I see no issue in using it. And I know analysis, like for the engine, we didn't do any FEA or CFD on it. It was all 1D stuff or RPA, which is itself 1D, and hand calcs and things like that to sense check. But for the rockets themselves, for the aerodynamics and the structures, then I know that they use ANSYS for doing that.
We've done a lot of fluid simulations on ANSYS, which is good fun at different speeds. And ANSYS can also do some nice FEA. I know that we've even done, worst case, some Fusion FEA. And like you said before, Fusion is not the best 3D design software, but I really like how easy it is to design things with multiple people, have multiple people contributing to a part. I think their part sharing on Fusion is really, really, really nice. For a lot of our final simulations, we will still use OpenRocket for all our rockets because it gives you stabilities, it gives you rough speeds, and it's actually pretty goddamn accurate. A lot of these like very simple solvers like RPA and like OpenRocket are actually really goddamn good, even though they're making a lot of like little assumptions. FEA wise, I think we've not. Usually we do safety factor engineering when it comes to
mental safety factors.
Mental safety factors. You figure out roughly how much you think it's going to be able to take, and you make it way stronger. For example, our shock cords on our next rockets are probably safety factored out the wazoo. They can hold so many tons of force because we broke one of our shock cords last time. We're going to try and make sure that stuff like that doesn't happen. But I think going into next year, it'll be interesting to use a bit more ANSYS and some other softwares to sort of optimize our airframes and our rocket designs a bit. But yeah, do we develop any of our own softwares? No, not really. I think the only time we develop software is within our avionics team, making deployment computers and making tracking. And for those in-house stuff that we're working on at the moment, we do write software for that.
And occasionally for like engine related stuff, for data processing, for stuff like that. A couple of scripts on the old GitHub. MATLAB. Yeah. No, I'm Python. I'm in Python. Okay. But yeah, we use that occasionally, but we don't really have one big like stuff that does everything. You know what I mean? It's like specific things we go, okay, we actually do need that. But in general, we just use the kind of the stuff that everyone else uses.
What electronics do you use on your rocket?
So most of our flight rockets, we will always use a commercial avionics backup. I think our favorite is the Raven, but we use
I like egg timer stuff. I'm team egg timer.
Egg timer stuff. We've got easy minis. We've got a bunch of easy megas. Pretty much every single one of our rockets that flies will have COTS computers firing all the main channels. I know that we are developing our MRAS Mini, which is our deployment board. Got Tracy, which is our tracking board. And then we've got Armadillo, which is our arming board.
Creative naming.
And all of those, we've designed the PCBs in-house and they've soldered it all together. And now they're writing the software for all of those boards each. So we are very tentative when it comes to in-house avionics, especially when it's like flight critical stuff, because I know a lot of teams have wrecked their rockets over in-house avionics. For example, Georgia Tech, their Material Girl rocket,
That was a cool rocket.
nose cone on the rail. And the only reason why that happened is because they designed their avionics in-house. And it's very difficult to design avionics and software that is so bug-proof and reliant, it can fly on like large aerospace rockets, But with that being said, we do have a program to make deployment boards, to make tracking boards, and a testing campaign, hopefully that will start in the next month or so, whereby we'll launch a lot of these boards in non-critical configurations. So with E-matches wired in, but none of those E-matches go into separation charges. So we can verify that the rocket works. And if we see that our design is actually reliable enough and it is repeatable enough, then hopefully, one day we'll be able to fly with in-house avionics as main flight computers, but I think we're still a little way off. Probably will always do cost backup because our design philosophy is try and make it goddamn work and try and give it the highest possibility of working. And if you're doing something that you absolutely know is going to work and you bought off a company to do a very specific task and they've tested it loads, then we trust that. In the same way, we also put a spot trace in most of our rockets as well, which is just a brick GPS antenna that you could probably drop from space and it would be fine.
Evolution Space did that, didn't they? We still managed to shred them on Calfa. I mean, the Evolution guy was like, those things are robust, man, but we found on Calfa it was definitely dead.
I think it was flying faster than its terminal velocity.
Goddamn
rockets in the rocket. If it was free from the rocket, it would have been fine.
Yeah, but it was inside and that was its coffin.
That was its coffin.
What launch rail do you use, and does it have any electronics on it?
I feel like this question is more for the liquid side of stuff. For solids, you just have, of course, the batteries on, arm it, and send it. But for the liquids, I like to have as little things on the rocket as possible. This is a repeated theme throughout this. As little as possible. So for Desert Winds, we'll have like a BOC. The actual ground support equipment is a nitrous K bottle hooked up to a servo valve that is the fill valve that goes straight into the QD underneath the rocket, and that there is the fill equipment. No nitrogen or anything like that. Because we don't have any electronics on the rocket, apart from the deployment avionics, which you can have big batteries for, which is fine. Just let that run almost, or just turn it on remotely when it's launched. Then we don't really have to worry too much about especially the batteries on the vehicle itself.
I think, to be honest, within the team, we don't. We try and keep our launch equipment to a minimum. I know lots of teams, as you put on your question there, do like on-rail charging of their batteries. They have telemetry and ground support equipment attached to the rails to allow them to turn on the rocket to verify things are working. But I think this is why I really like going to FAR and why we want to keep going to FAR, is because they have such a large array of launch rails that you'll almost certainly be able to have a launch rail that fits the rocket specs. But also, it's very easy to access it. And if you make sure your ground support equipment is quite minimal, or all our cameras, our batteries, our arming is all within the rocket rather than having it on the pad side, it's easier. Obviously, you can't do that with liquids because you're going to need some form of ground equipment. But I think you'd agree, Dominic, if I said we're trying to keep it as simple as possible.
Oh yeah.
Compared to some of the ground equipment you see set up at EuRoC, or some of the launch rails that you see set up at S-Range, or even at FAR sometimes. There's like that LOX hybrid that had all fucking...
VAR. They had their own rail. They had their own rail at EuRoC that was like way bigger than the standard ones.
Yeah, so I think it'd be nice to design a rail at to be fair, but I think in the meantime,
we'd rather design the
rockets. Get the rockets easy to integrate, easy to put on the rail, easy to turn on, and easy to launch. That there is flexibility. You can take it to lots of different launch rails. Apart from our novel recovery system, which is the Steerable Parachute System, usually to be fair, we've sort of gone back and forth between the two main recovery design philosophies, i.e. having your drogue and your main in separate compartments, and both of them are fired off separately, or having your drogue and your main in one compartment and you use a tender descender or some kind of release mechanism to trigger the larger parachute. Last year, for our separation mechanism, we had CO2, a quite complicated system, to be fair, that was quite over-engineered. This year, with the mentality of just trying to keep stuff simple and easy, we use Blackpowder for vast majority of our separation events. We thought about mechanical separation, stuck with Blackpowder because it's very reliable.
I think on that as well, just if I interject, then it does, like, mechanical sep is quite like attractive at first, but Blackpowder doesn't lie, really. If you put enough in there, it's going to go bang. And we can test this stuff at MRC as well, which is nice, because of course there's like pyrotechnics operators there. Yeah, I know a lot of teams do kind of mechanical separation, but there's a lot of added, again, complexity to that, which is something that we like to avoid. So just sliding coupler and a Blackpowder charge on one end. And we have these little caps as well, because there's the whole thing of Blackpowder at high altitude not burning too well, but we've got these little caps that maintain it at like 1 atmosphere of pressure.
I think because we've been doing it for quite a while now, and it is one of the most reliable ways of separating stuff. Also, a lot of mechanical separation systems are way heavier for our altitude shot rocket for Karman Bravo. Considering that we failed recovery last time, we made design decisions to have separate avionics, separate parachute bays for our main parachute and our drogue parachute, so that we wouldn't have to rely on the drogue opening for the main to then open later, and use Blackpowder charges where we can for the separation system, because it's way lighter and way more reliable, and for our deployment. Whereas I think for the Desert Winds rocket and for our novel recovery rocket, we're going to have to use some kind of line cutter system where you blow up the nose cone, deploy a drogue, cut a line, and then your main comes out. I remember we were having lots of conversations as to why Karman Alpha failed. And one of the big things we noticed was that when you have, when you're kicking out your parachutes from the top or just kicking out your nose cone, the rocket is very stable. You still have a very long body with fins at the end and most of the mass at the top. The rocket is going to want to sort of follow the free airstream back down to the ground. So for Karman Bravo, we've tried to split our apogee charge in the middle every time and get as weighted and two equally weighted halves of the rocket to sort of guarantee that it's going to be as unstable as possible. We're going to fall back down to the ground in a very slow and chaotic manner, not norm dart, which we got last time. I think that is very important. I think that one of the biggest things that I'm very happy Desert Winds is working on, and I'm very happy that Recovery is working on, is getting that drogue deploy, and then you cut your tender descender or cut your line cutter, and then you get your main deploy, and making that system as reliable as possible. But it is a much more complicated system, and it's much more unreliable.
Yeah, especially for Desert Winds, we kind of have to use that because we have the architecture of the rocket is the tank is the body tube. We have on the bottom of that, we have the fin can with all the valves and the engine inside of it. And then on the top of the tank, you have the nose cone that slides directly onto the tank. A slim rocket. And so we've had to put all our avionics and recovery in the nose cone. So that forces you to do that kind of deploy both parachute bag and tender descender line cutter, whatever. You can't really do that split in the middle with the architecture. So it isn't it's more so out of necessity that we're using that.
I think we're going to really try and master that recovery system. I know that we did it last year. It was the way Calfa was trying to recover itself. It didn't work. I know that top stage didn't work more because the computers were dead by the time it got to apogee. They'd been long fried and cooked. But the first stage, we were literally just firing out a parachute out of the top of the rocket with no weight attached to it at all, really. And it just shredded. It inflated and shredded immediately, and the rocket continued down to the ground. I think that, to be fair, on a little side note, I think that one thing that Recovery has done really well with their design for their parafoil is having a system by which it's sort of separated compartments within the nose cone. So your first drogue charge fires, and there is only the drogue in that compartment, and there's sort of a plate underneath that sort of seals your main parachute underneath. And then we're using the tender descender to release the plate rather than release the parachute, so we can have swivel links. And I do think that There are methods like that we can make it much more reliable, much less likely to get tangled. But considering how many rockets have fallen out of the sky at EuRoC trying to kick off their nose cone, considering how many rockets have
in general,
like firing off the nose cone and having all your weight and your stable rocket going back down to the ground, and a drogue trying to keep it all in control, it's difficult to do. It's difficult to do. But hopefully we'll get it down very soon.
Yep.
What is the payload of your rocket?
Because the competitions that we go, I mean, for Mac Rahanish, Mac 24, then the payload is the steerable thing itself, because that's what they're trying to test and that's what they're going off. Desert Winds has no payload. It's just to kind of launch a liquid. Neither does Karman Bravo, because it's just to hopefully get the altitude board.
Why would we add more weight?
More weight, more complexity. I know for Calfa, we did have, but there's some other societies within Sheffield that had payload, like their own PCBs on board Calfa. Unfortunately, that didn't prove very useful to them because theirs got shredded as much as ours did.
There are lots of other projects at the uni that will. So there's a satellite project called Sunsat. There's another sort of aerial vehicle project called Sunstratos. These teams are sort of kind of linked to us. They're kind of linked to the university. For the Mac Rahanish rocket, they will be Sunsat are launching the payload, because we do need a CANSAT.
Oh, yeah.
So Sunsat are going to design the payload. But usually when we need a payload or a scientific experiment or something like that, we will outsource it to another project, or another project will come to us and be like, can we launch this on your rocket? Because we want to. But currently we're very much set up as like a launch provider, launch service.
Yeah, sure.
But no, I think that for our altitude rocket and our liquid rocket, payload is not the priority. When it comes to competition, it is nice to make it a full project and not just sort of DOS it off and be like, oh, it's a random payload. We don't really design payloads, and actually give it to a team that sort of specializes in designing payloads.
Yeah.
But it still comes within the University of Sheffield, but it wouldn't be Sunride as much for now. Maybe in the future we'll have a sub team that does a payload.
That's for next year to decide.
That's for next year to decide, isn't it? Yeah.
Do you like and play Kerbal Space Program?
Yes, I remember. There's a bit of a story. It's just, I think, the first domino in the chain that led me to end up. I mean, maybe not the first, because my grandparents' house, their room that we always stayed in was called the Rocket Room, because it had rocket decorations, which was really adorable and stuff like that. So maybe planting the seeds way back when I was like 4 or 5. For KSP specifically, it was back in I want to say 2016. Or maybe earlier, I can't remember. It's whenever No Man's Sky came out, if you're aware of that game. When it first came, it's good now. I enjoy it now. But back then it was rubbish. But for whatever reason, I really wanted it. So I tried to get it on my laptop, but my laptop couldn't take it. So I was like, oh, I really wanted to play that. Let's look for alternatives that I could play on my Xbox, because my laptop was really crap and No Man's Sky wasn't available on Xbox at the time. And so I found KSP, watched the trailer, I was like, that looks really fun, actually. So I got it and was hooked. For many years of my life, I played KSP, mostly in sandbox, just making random stuff that normally didn't work and stuff like that. That got me into model rocketry as well. I got a couple Estes kits to launch in my local park, which was fun. Yeah, I think KSP is great. It gives you an intuition for rockets, which I don't think you could really get anywhere else. Like there's actually a module next year that I don't think I'm taking, because I want to take another module instead. But it's about kind of orbital mechanics and stuff. And pretty much, if you've played KSP, then you can intuitively answer the questions.
It's like docking. If you've ever tried to dock two things in KSP, you actually sort of get logic of how orbital.
You lower your orbit and stuff like that.
Exactly.
Yeah, it just gives you an intuition for that, which I think is amazing.
I always love. I think I got Kerbal Space Program in year 8 or year 9.
Yeah,
early on.
Yeah, that's when I got it. Yes.
One of my friends who lived literally just across the road from me, he got it, and I was like, "Oh my god, this game is amazing!" So I got it, and we used to play these moon races where we would sit down together after school, and you could use time warp, but the aim of the game was literally from when you both started playing the game, who could land Jeb on the moon first. And so it's like a speed run, and you can use like time warp, but obviously if you time warp too much, you could kill your whole mission immediately. So it was like, how quickly can you build the rocket, get it onto the pad, launch it up into orbit, time warp efficiently enough that you actually get to the moon first? And I remember we used to play that for years and years and years, and basically just got really good at Kerbal Space Program.
And in terms of, again, like the stuff you learn, again, you've got the Scott Manley thing on the slide. Oh, I love Scott Manley. But the things like this, what KSP doesn't teach you, and you're like, okay, this is interesting. And then you kind of get more and more into the actual in-depth technical aspects. And I mean, like now, for example, I don't actually play KSP because I just built real rockets. But I have a huge amount of respect for KSP, and it's in applications. Like I didn't when I was applying for Sunride back last year. Is that it? Gosh, that's last academic year. I didn't know whether to put it in, but then I was like, oh yeah, go on, I will. And now, like this year, when I was looking through applications, then anyone who played KSP, I was like, oh, okay, incredible, you know.
No, I remember seeing Dominic's application and being like, good KSP, like that.
Yeah. It definitely shows a passion for space and aerospace in general, and does give you like stability and stuff like that. That you know, as fundamental as it is, KSP does teach you that initially, and it's just fun. It's a
brilliant game. And Scott Manley is just the into the space industry.
You
start watching Scott Manley videos, and then suddenly you're watching his video about, I don't know, some old fucking weapons program from the USA, you know, their Thor missiles, and you're like, this is the coolest shit ever. Anyway, I love it so much.
Do you have any big announcement or dream?
Yeah, Desert Winds, July 15th, June 15th, look out for that. Karman Bravo, June 15th, new altitude record, look out for that. July 14th, Macrahanish rocket, steerable parachute system, first time in the UK. That'll be fun.
Whenever race space, I actually don't know what it is.
Whatever the hell you guys decide you want to do.
And also next year as well. Maybe this is an option. We're hoping to kind of set up a test site to test engines, which would be really exciting. Taking inspiration from ICLR, hence why we were down there a couple of weekends ago, which would be really cool. And there's talk of Hopper, maybe. I mean, but that's very kind of,
it'd be cool.
Not official, not decided. It's kind of will be decided in future years, kind of stuff. But it'll be a really interesting project to take up if we kind of want to delve more into that aspect of things. Since we're kind of very open, there's nothing too surprising. But yeah,
lots of exciting projects though.
Yes.
Keep an eye on Sunride. Hopefully, there'll be lots of cool stuff happening over the next.
Whether it works or doesn't work, there'll be cool.
There'll be videos. There will either be explosions or flying rockets.
Yeah,
it'll be cool.
Do you have any advice to young rocketeers?
Actually, just build them.
Yeah,
I know that's how I got into rocketry mainly, was when I was like, just watch YouTube videos with those sugar rockets, which is totally not allowed. But I love doing that. I'm not encouraging sugar rockets. I'm encouraging going to Midlands Rocketry Club or a similar rocketry site and doing it properly. But make them, build them, go out there and get a 3D printer. If they're not difficult to build, you can spend a weekend sitting down with some arts and crafts stuff and make a little rocket. And I don't think anything gives you the knowledge or the experience as just doing it.
I think another piece of advice from me, and I wouldn't say this is specific to young rocketeers or anything. I mean, of course it applies, but it's just speak to people who've done it before. Like just get advice. Don't try and battle it yourself. People have done this for decades, longer. It's just that they have a lot of good experience. So don't be afraid of asking for help from others. I know, but when we were making our liquid, like this time last year, I knew nothing about liquid propulsion. I'll be honest, I knew absolutely nothing. But through just speaking to people and getting advice, that has been a huge help and actually allowed us to get where we are currently with our liquid engines. And when you're young, of course, do it safely, because rockets inherently are dangerous, but you can make them safe, and do make them safe. But you could do that through speaking to people, going to your local launch site. There's a couple in the UK. Midlands is Sara in Scotland. I think there's a couple others, but I can't fully remember. And just kind of, if you're just starting, I'd recommend a couple kits, like Estes kits. That's what I started with. And just launch them in your park, and then you can work your way up to bigger kits or making them from scratch yourself. But yeah, I'd say just get on with it more so than anything. Yeah.
Don't let your dreams be dreams.
Don't let your dreams be dreams, exactly.
What are your favorite space movies and YouTubers?
Apollo 13.
Scott Manley.
Matt Lauer. I love Matt Lauer. He used to do some KSP stuff.
Yeah, he went to the University of Sheffield, didn't he?
Yeah, he did. He did.
He was not
Sunride, and that was one of the coolest things.
Yeah. He commented on one of our videos, and I was like, oh, I tried not to fanboy too hard. But I definitely did. Matt Lowen, yeah, he's really cool.
Very good one.
Scott Manley, obviously. Everyday Astronaut, yes. These are all the ones that I watched.
Pegza.
Oh, no. Okay. I'd say I have strong opinions about that man. He's entertaining. Don't follow his example. I'd say in Texas, I was a fan of his stuff. I just think that he could promote safe practices a bit more. Because oh my word, I get scared when I watch his stuff. I get really scared. But yeah,
it's very true. Yeah. There's stuff made here. Maybe not space, but he's like this brilliant at-home engineering engineer who did like the basketball hoop that moves and the basketball. He did the pool cue that has like the robot at the end that can hit the pool perfectly into the hole every time, even if you just arbitrarily sort of swing it at the fucking table. That's brilliant.
Yeah. In terms of space, I like The Martian as well as a film. That's a banger. I've not actually watched Gravity. I need to watch Gravity.
That's the first 12 film I ever watched. I just turned 12. You know, 12A, like the
Peggy, not Peggy. Yeah, I know what you mean.
You're only allowed to watch it if you're 12 or above. And I just turned 12. It was my 12th birthday, and my dad was like, "Right, we're going to go and watch Gravity." And yeah, I like that film.
Star Wars.
Star Wars.
Does that count as a space movie? Surely it does. It's in space.
Okay, Dune. I like Dune. That's a good one.
Yeah, that's in space as well.
All sci-fi stuff now. Anyway.
Do you have any questions for me?
Yeah, I mean, how did you end up interviewing so many teams?
Got to know many different teams, both from contacting them on LinkedIn and from meeting them at EuRoC, since I've already been there for the last 2 years. So I've known many different teams, and yeah, I ended up interviewing them.
How did you get into rocketry in general?
Well, I've been to rocketry from quite a long time. I started making sugar rockets when I was quite young.
What would be the main point that most teams bring up? Like, because you've spoken to so many, then what's like some common any like similarities or differences in styles between teams that you've noticed?
Everyone says they want to reach the Karman line eventually.
Yeah.
There are many people who say they want to make liquid rockets eventually. Always more teams who are doing liquid rockets, and also the parafoils.
What would you say is one of the most common challenges that you've noticed rocket teams face? What's like a common complaint or challenge that you've heard echoed throughout most of the rocket teams?
Well, there are definitely many teams say they don't really have enough time to get the rockets ready by EuRoC, so they have to rush quite a bit. For the liquid rockets, they always have problems with connectors, the fuel tanks, leaks. Also, avionics gives problems quite a bit of the time before launch. And after launch, the main problems are just recovery. Many times the recovery system does not work.
Yeah, interesting
I've first had some rockets fail recovery.
There's some videos
They make a brilliant sound. I would say on a quick final point, there's a terrifying video that will probably come out in the documentary of the first stage of Kalfa coming back down to the ground, and it makes a terrifying sound that it's coming back. Because you're absolutely right, recovery is really difficult.
Multiple rockets at EuRoC which have come down very fast.
Yeah, I can imagine.
I remember seeing a picture from EuRoC 2022, so 2 years ago, and it's I can't remember what team it was, but it was literally just flattened. It was like this crater, and you had a 4-meter rocket that just kind of squidged itself down into this little compact pile of twisted metal and tanks.
Usually, if a rocket crashes down, then they usually display on the table the fins. The last part of the rocket usually is in relatively good conditions, let's say. So the fins stay attached to a bit of tube, and many times in liquid rocket engines, the combustion chamber also stays intact. Then
I hope ours does.
And you have some small pieces of carbon fiber and some very deformed aluminum.
That sounds very similar to the wreckage of Kalfa. We actually had a really interesting wreckage piece from Kalfa, because the fins were retained in such a way where the only thing stopping them from going up was the carbon fiber tube, which you'd never like that's not a problem normally, and you wouldn't ever design to stop them from going up because that's not how they're loaded. But when it hit the ground, just on the inertia of the fins, it sliced through the body tube, so all the fins are like halfway up the body tube at different angles, and it's a really cool display piece. And it takes often, if people haven't really seen rockets before, they ask us, "Oh, why did you put your fins there?" And we're like, "We didn't put them there. We didn't put them there. The ground did." Inertia.
Offset and one's like halfway up the rocket.
Yeah. It's like, oh no, it's a really innovative aerodynamic strategy for maximum stability, actually. Yeah, no.
Hopefully, I think our biggest mission this year will be to get some rockets back from some brilliant flights without them being a twisted mess of aluminium and little shards and bits of carbon fiber.
Yeah, I mean, it was quite funny when we were in the Best Western in Mojave after we'd got Calfa back, and we needed to scrub it down of all of its like APCP and black powder residue to make sure that the plane ride back was as smooth as possible. Then yeah, we were just scrubbing this wreckage, this twisted carbon fiber wreckage, in a bath with some soap, and you can still smell the soap on the wreckage on certain bits in a box.
And I'm sure there's still carbon fiber splinters in that poor hotel room.
Yeah, I think there might be a bit of Calfa dotted around.
A bit of Calfa dotted around, but no.
Yeah.
Thank you so much, Eto, for doing this.
Yeah, it's been a really, really great. Thank you very much for having us. More than anything, I was very excited when I saw that you wanted an interview with us.
Yeah, I don't know. I've watched many of your interviews with the other rockets. It's brilliant fun being able to spy on them and figure out what they're doing. You're the vessel of that, Eto. So
yeah, it's very nice
to be able to do this interview.
Oh, thank you for coming.
And yeah, if you ever are, will you come to England much? I don't know. If you're ever in England,
drop Alistair a message. Drop Alistair John a message. He's our academic supervisor and the guy who runs Race to Space. He'd probably invite you along to that if you want to come. Because I know he's said some other guy can show up. But yeah, if you drop a message, you might well be able to sneak into Race to Space and watch some hot fires, which would be fun.
Very exciting. And also just come and visit some of the teams if you're ever knocking around England. I know every team will show you around their little rocket shop. I'd love to give you the tour at some point if it ever happens. Or see you at EuRoC.
Yes.
We end up coming to EuRoC. That would be really nice as well. I think after when you release it later, Eto, will you post it on LinkedIn? And do you want us to basically repost it on LinkedIn, or do you want us to make our own post about it on LinkedIn, or both?
Well, I will make a post about it, but if you can repost it, that would be nice.
Mm-hmm. Yeah, can do. We'll get the official.
Yeah, will it be released mainly on YouTube, or will it be released like?
Well, I will release it on YouTube, and then I will put the link.
Okay. Cool. Thank you so much, Eto. It's been lovely.
Yeah, cool. I guess I'll head off then.
Yeah.
Thank you very much.
It was lovely.
See you around.
I'll see you around.
Yeah, I'm looking forward to who you're going to interview next.